Hey guys, welcome to the second half of chapter 14. Here we're going to just expand on what we know about acids and bases. So we're going to talk about some salts that behave like acids and bases. And then eventually we'll get into the application of that information when we talk about buffers. So that's kind of the path we're going to take through this chapter. So let's get started on these idea of salts. So when I say the word salt, of course, sodium chloride is probably the one that pops in your head. But remember that a salt is defined as an ionic compound that dissolves in water, okay? So certainly sodium chloride fits the bill, right? It's an ionic compound, metal and nonmetal, and we put it into water, it will dissolve in water. But our general definition fits more than just sodium chloride. So we've got lots of other things. Okay. So here's an example of a salt. So it's water soluble, it's ionic. So here we have sodium bicarbonate. So sodium Na, bicarbonate is HCO3. So ionic compounds can also include polyatomic ions, and this is an example of a polyatomic ion. So we put this salt into water. It will dissociate or break apart into its ions. That means it's water soluble. Now, sometimes these ions can affect the pH of a solution. Okay. So sodium in this case does not affect the pH. And I'll talk about why and how I know that in a little bit. But sodium is what we call a spectator ion. It just kind of sits around and watches the show. It doesn't really do anything to affect the pH. Bicarbonate, on the other hand, does affect pH. So when bicarbonate is in the presence of water, it actually acts a little bit like a base. So here's our bicarbonate ion. I said it's going to act a little bit like a base. So a base is a proton acceptor. So this sodium bicarbonate is going to accept a proton. And we see that it's got 2 hydrogens now instead of 1. It does this in the presence of water. So water behaves a little bit like an acid. So proton donor. So it gives away one of its hydrogens, and it is left with just the hydroxide ion. So sodium, bystander, just observing. Bicarbonate has a basic effect. It acts as a base, and it will accept a proton and leave hydroxide or increase the amount of hydroxide in solution. So while I am very interested in what this bicarbonate ion is doing, because we're in the acid-base chapter, I care about how that pH is changing. While I'm very interested in what that bicarbonate ion is doing, it doesn't exist by itself. I can't walk to the shelf in my lab and grab bicarbonate. It just doesn't exist that way. It always exists as a pair with a counter ion. I can walk to into my lab and grab a bottle of sodium bicarbonate. So sodium is that counter ion. It is there, but it's just kind of sitting around and eating popcorn and watching what's going on. It's not doing anything. So how did I know that sodium was a spectator ion? How did I know that bicarbonate was going to affect the pH? The next thing we're going to talk about is kind of a list of rules to help us determine if something is going to affect the pH or not. So the first skill we need to get before we start applying this to different scenarios, the first skill we need to get is how do we determine if it affects the pH? So here's a list of rules that's going to help us. If it is a cation, so that's just a fancy word for positively charged ion. So if it is a ion from group 1 or group 2, it will not affect the pH. So it'll just remain neutral. It'll remain a spectator ion. Okay. So we've already seen the example of this. Sodium was the example. It just simply spectated in the previous example. Okay, so let me just write that explicitly. So example of this would be like sodium. Now, as I said before, these ions are not going to exist as just sodium by itself. So what we would do is we would look at that compound, the one we just were looking at. Okay. We would handle these as two separate ions. So we would handle them as sodium and then handle them as bicarbonate. But in this case, the rule that we're focusing in on is the fact that sodium is a group 1 metal. And I would say, oh, that's a group 1 metal. Sodium's not going to have an effect. It's just going to spectate. Okay, so that's how we're going to answer these questions. Number 2, so sticking with the theme of positively charged ions. So the next 2 rules are going to be cations, positively charged ions. So a cation from a transition metal will affect the pH, and it'll affect the pH in a acidic manner. Okay. So an example of this, I might have a compound like iron hydroxide. I don't know, I'm making this up. Okay. So this guy right here is a transition metal. And it is also a transition metal with a really high charge. It has a 3+ charge. So a transition metal, particularly ones with high charges, those will have an acidic effect. So I put this iron in the presence of water, and it will behave like an acid. It will donate a proton. So the next one we're going to talk about, continuing with the positive ions, is cations from weak bases. As I've said before, weak bases are a little bit more difficult to identify, so I certainly would help you out with this one. But certainly the poster child for this one would be NH4. So this is ammonium. It is a weak cation from a weak base, so the weak base is NH3. So ammonium from ammonia is probably the poster child for cation from weak base. So probably one you'll see the most often, and that one would certainly have an acidic effect. Now we're going to move into negatively charged ions, so-called anions. So the last 2 rules have to do with anions. So anions from strong acids would be neutral. Okay. So again, it's important that we know the big 5, we know strong acids, so that we can identify if they are anions. So just as a reminder, our big 5 are HCl, HBr, HI, HNO3, and H2SO4. Okay. So when I say anions from strong acids, I'm talking about any of these guys right here. So for example, if we had like sodium chloride, right? We would say, okay, chlorine is going to be the anion. Is that one of the big 5? Yeah, it's one of the big 5. It's right here, HCl. So this would have a neutral effect. It would be neutral. It wouldn't affect the pH. So if it's one of these 5 anions, then it will not affect the pH. It'll just be neutral. So if it's an anion from a weak acid, so if it is not one of these 5, if it's anything else and it's negatively charged, it will have a basic effect on the solution. So the example that we saw before, remember, was the HCO3. So that is not one of the big 5. So it's from a weak acid, and it would have a basic effect in solution. So let's put this into practice. So it's not going to be that I'm going to put like chlorine and be like, is that neutral, basic, acidic? You're going to be given these salts. You're going to be given two ions that have come together in a compound, and I'm going to say, here's a salt. What would happen if I drop this into water? Would it change the pH? So kind of the stepwise process here is going to be to break the salt into its cation and anion. So you would have, NaCl. The first step is to break it apart into sodium and chlorine. Just kind of see what you're working with. Next, you're going to identify which of the ions would be neutral. So that would be just kind of using your list of rules, determining if it's going to be neutral or not. And then if there's any that are remaining, decide how that's going to affect the pH. So let's take a look at an example. So here's our example. The first thing we're going to do is break it apart into its ions. So this one contains a polyatomic, and it might be a polyatomic that you're not terribly familiar with. But if I take potassium over here, so if I take that ion that I am familiar with, anything else that's left is going to be the anion, okay? So when in doubt, this always breaks apart into just two compounds. Take the one piece out that you are familiar with, and then whatever is left is your polyatomic. All right, so let's decide if this is going to have an effect on the pH. So the first one I'm going to look at is potassium. So going back to my list of rules, I'm just going to start from the top. So potassium is a cation. It's a positively charged ion. Is it from group 1 or group 2? Yeah, it is. It's from group 1, right? So potassium's going to be a spectator ion. It's just going to simply watch what's going on. So in this case, potassium would be neutral. Now let's look at our anion, this guy over here. So what are our rules for anions? Is it an anion from a strong acid? So is it one of the big 5? No, it is not one of the big 5. So that must mean it's an anion from a weak acid, so it would have a basic effect. So I break apart, I get rid of any neutrals, I decide this is going to affect the pH, and it's going to have a basic effect. It's going to cause the pH to go up, to increase. So go, more towards the basic side. Okay. So that's just kind of a general overview of looking at salts, determining if it's an acidic or a basic salt. I'll have another video that'll have some examples of this, and then we'll take this skill and we'll apply it to a different type of problem. So this would be like step 1 in a series of steps to solve a problem. I hope you guys found this helpful.